Hello, now we are going to look at ratio and proportion, and we'll start off by looking at what it means to have a ratio in its simplest terms. So we have 30 cent is to €1.20. Our first issue is that we're not comparing like with like. 30 cent is not the same type of thing as €1.20. So we need to get these in the same units. So we'll convert everything to cent so we don't have to deal with decimals as much. So our €1.20 needs to get multiplied by 100 in order to turn it into cent. There's 100 cent in a euro. So when we do that, we get 30 cent is to 120 cent. So now we're comparing like with like. Just like with fractions, we need to have the same denominator. If we can with ratio, we're going to write stuff in the same units so that we can compare them more meaningfully. Now, in its simplest terms means the smallest whole numbers that we can write the relationship in. So in this case, we have a common factor of 30. So if we divide that out, we'd have 1 cent is to 4 cent. That's the smallest whole number ratio that we could write that in. There's no common factor between these other than 1, and they're written as whole numbers. So that's what we mean by simplest terms. Now looking at more of a story-based ratio type question, we have Cole, Grace and Jay pay for a gift in the ratio 2:8:6. If Jay pays €39, how much is the gift and how much do their friends pay? So Cole is to Grace is to Jay is in the ratio 2:8:6. So if Cole paid €2, Grace would pay €8, Jay would pay €6. I can see here that this is not a ratio written in its simplest terms, so I'm going to divide out the common factor. I'm going to get rid of my common factor so that I have a simpler ratio to deal with. So for every €1 Cole pays, Grace pays €4 and Jay pays €3. And I know that Jay pays €39 in total. So if I want to know how much the gift costs, that means I need to know the total amount that all of the friends paid. So that means I need to know what fraction of the total €39 is. So what total would I be dealing with? Well, to figure that out, I look at the smallest amount of total euros, that I would be able to use to have one person pay €1, another person pay €4, and another person pay €3. So the groups I'm dealing with, the smallest groups I could be dealing with, the smallest amount of money I could be dealing with would be 1 plus 4 plus 3 is going to be €8. So the smallest amount of euro we could be talking about to break up our ratio this way would be €8. So we're dealing in groups of 8. Now that simplifies my life because I can now say that Cole pays 1/8 of the money, Grace pays 4/8 of the money, and Jay pays 3/8 of the money. So what I can now say is I'm talking about Jay, so I'm going to put Jay down here so that I'm clear about what I'm talking about. These questions don't have the nice structure of equations, so it's important to put in as much structure as we can. So Jay is who we're talking about. That's 3/8 of our total. We now know is €39. Well, anytime I have a ratio and I want to talk about changes, I need to find out what the total is, which is 8/8. So I need to go from 3/8 to 8/8. So what I'm going to do is find one of the thing. I'm going to use the unitary method. So to find 1/8, I'd have to divide both sides by 3. So I know that 1/8 is going to be €13. So I now know 1/8 is €13. So to find the total, if I know 1/8 is €13, and I need to find the total, which is going to be, €13. I need to find the total, which is going to be 8/8. So I'm now going to go up to the fraction that I want. I went to 1/8 so that I could go to whatever fraction I wanted, and for the total, that fraction I want is going to be 8/8. So the total is going to be 8/8 is going to be €104. That's the total cost of the gift. Now Cole, I wanted to know what Jay's friends paid as well. So Cole just pays 1/8, which I already worked out was €13. And Grace pays 4/8. So I go to the relationship that I know, just like I did for getting the total. 1/8 is €13. And I multiply both sides by 4 to get up to Grace's fraction, Grace's proportion of the total, which is going to be 4/8, which is going to be €52. And this is our method in general. If we know a particular fraction of the total, a particular proportion of the total, we find one of it, or 1/8 in this case, it could be one out of whatever total, and then we go up to whatever fraction we need. That's how ratios tend to work in general. We use the unitary method all the time, finding one of something and then the amount that we want. Now, if we look at direct proportion, which is a form of proportion that we deal with a lot, we have the example of a mercury thermometer. So a mercury thermometer, or in a mercury thermometer, the mercury expands as it heats and rises up the tube. So we have a bulb of mercury at the bottom of a thermometer. As it heats up, as the thermometer heats up, that mercury expands and it rises up the tube. That's how we read the temperature, how high we've gone up the tube. Now, very importantly, this thermometer is set so that at 0 degrees Celsius, the height of the mercury in the thermometer is 0 centimeters. We must have that for direct proportion, and we're going to look at that in more detail in a minute. So this is very important for how we're doing this calculation and for direct proportion, that at 0 degrees, the height is 0 centimeters. Also, at 20 degrees, the height is 15 centimeters. And this gives us our relationship between degrees Celsius and the height of the mercury. So how hot is it when the height of mercury is 25 centimeters? Well, we write down the relationship that we know. 20 degrees Celsius gives a height of 15 centimeters of mercury. Very much like the ratios that we were just doing, we find out, if we want to know 25 centimeters height of mercury in degrees Celsius, we need to find out what 1 centimeter gives us in degrees Celsius. So we are changing the centimeters, so we need to know what 1 centimeter is, and then we go up to the number of centimeters that we want. So we end up with 4/3 degrees Celsius gives 1 centimeter. So at 1 centimeter of mercury, we would be at 4/3 degrees Celsius. And now we go up to the number of centimeters that we are interested in. So we go to 1 of something and then to the amount that we're interested in, just like we did with our ratio. So we multiply both sides by 25. And we end up with 100/3 degrees Celsius gives 25 centimeters, or written as a decimal, that would be 33.3 recurring degrees Celsius gives 25 centimeters of mercury. And that's what we want to know. So it's 33.33 degrees Celsius at 25 centimeters of mercury height. Now, how high is the mercury when the temperature is 30 degrees Celsius? Well, we go to the relationship that we were given at the beginning. 20 degrees Celsius gives a height of 15 centimeters. I want to know a different number of degrees Celsius, so now I need to find 1 degree Celsius gives me what in the centimeters of mercury. So I need to divide both sides by 20 in order to get the 1 degree Celsius gives me what in mercury. And it gives me 3/4 of a centimeter of mercury. So 1 degree temperature rise would give me 3/4 of a centimeter rise in mercury. Now I want to know what that is when I go up to 30 degrees. So I need to multiply both sides by 30. So 30 degrees Celsius gives 22.5 centimeters of mercury. Now, we've been doing this as a proportion type question, but it's important to understand that direct proportion is actually a straight line relationship. As one thing goes up, something else goes up by the same amount. And that is the description of a linear relationship of a straight line if we were to graph it. So this is our relationship graphed. As the temperature in degrees Celsius goes up, the height goes up. And critically, for direct proportion, this business of at 0 degrees, the height was 0 centimeters, our straight line goes through the origin. So another way to write a direct proportion where the height is proportional, directly proportional to the temperature, we would be able to say that the height is equal to some constant, which we often call K, times the temperature. So to know the height, we'd multiply the temperature by a particular value. And we can work out what that value is if we are certain that we have a direct proportion. Just as a reminder, this is the same as y equals mx, and the constant is 0 because we are crossing the y-axis, the height axis, at 0. So how would we work out the value of k? Well, we know that the height is 15 when the temperature is 20. This was our original relationship that was given to us, dividing both sides by 20. We would end up with k is equal to 3 all over 4. So our relationship would be the height is equal to 3/4 of the temperature. We may notice this is also the slope of our line. This is the m in the y equals mx formula that we have above. So this would be the slope of this blue line. It's how the height changes as the temperature changes. Now let's have a look at in some sense, the opposite of that, where we have inverse proportion. So 4 lawnmowers cut the grass in an estate in 5 hours. So it takes 4 lawnmowers 5 hours to cut all of the grass in a big housing estate. How many mowers would be needed to do it in 2 hours? Well, what we can say now, we know that 4 mowers would take 5 hours. Now, unlike last time, if we decreased the number of mowers, we'd increase the amount of time. It would take us longer to get the job done if we had fewer mowers. So, if we want to change the number of hours, so we want to know the number of hours it would take, the number of mowers it would take to do it in 2 hours. So we state our question, how many mowers is that going to take? We need to find out how long it would take us to do the job in 1 hour. So we find 1 and then we go to the number that we are interested in, just as we did before. So 4 mowers take 5 hours. So if I needed to get it done in 1 hour, I would need 5 times as many mowers. So if I'm dividing by 5 here, I'd need to multiply by 5 here. 1 hour, getting the job done in 1 hour would take 5 times as many mowers. So that means 20 mowers would be needed for the job to take 1 hour. And then if I need to know how many people would be needed for doing it in 2 hours, that would take half as many people. So for it to get done in 2 hours, that would take half as many people. So that would take 10 mowers. So how long would it take 8 mowers? Write down our relationship. Generally, we'd need to find out what 1 mower would take. How many hours would 1 mower take? And they would always take 4 times as long, because we only have 1/4 of the mowers. And then 8 mowers would take 1/8 of those 20 hours to get the job done. Or we could have said twice as many mowers would take half as much time here. Now this relationship is time is to 1 all over the number of mowers, and can be written like this, and we will